Okay, I'll give you a few minutes to work the warm-up that's on the board. We get a few more people in here. And so remember, you can use your notes from yesterday. So you might need to follow all the steps that we did. What are you going to do to get from general form to standard form? What do you have to do? Like, what's the big idea? Yeah, put the X and Y terms together. You're going to complete the square is kind of what I'm looking for. So you're going to complete the square for both X's and Y's. And then once you finish that, and you get it into standard form, then you can state the center and the radius of the circle. Okay, so let me give you, I know these problems take a little bit, so we'll get our attendance while you guys.
I'm using two. Just want to check where the A's are. You see them on the map.
Okay. Oh, this, I know this one just joined. Okay. Yep. Okay. All right, so I just put in the chat, and for you guys here, if there are any homework problems we need to work, let's do it. So we have our quiz tomorrow. So if you guys have questions, let's get them answered today. Okay, so I know that's one problem, but it takes a while. So I had a request to do question 3 from Delta Math 5-2. Any other problems we're having trouble with? Andrew, any problems? We good? Anybody else? Question 5 on Delta Math. Which day of Delta Math? Last night's would be 5-3. On last night. Okay, question 5. Okay. All right, do you want me to just give you the answer and see if you got it right? And then if we need to, we'll work it. Is that good? All right, so when I convert it to standard form, I should end up with how do we do? How about you guys out there? Did you get it right? Just type in yes or no in the chat. Okay, should we work it? Yeah, go ahead, Micah. Okay, so that's the next step. The question is, what did we do on the radius? So I got lots of yeses. That's good. A couple no's. The next step was to list the center and the radius, right? So the center would be what? 2, 9, positive 2, positive 9. So I changed the sign, right? And then the radius, remember the standard form of a circle is equal to r squared. So what would the radius be? Other way around, right? The square root of 10. Okay, so you're going to take the square root of the number that's after the equal sign. And so on the quiz tomorrow, we have a quiz tomorrow, right? On the quiz tomorrow, your quiz is in Go Formative. You will enter, you'll type in your number answer using the keyboard there. And you're going to type the square root of 10. Do not put a decimal answer there. Okay, did everyone hear that? All you people out there hear that? Okay, on the last quiz and test, a lot of people missed problems because you didn't put the answer in the correct format. If it says to give an exact answer, let's go over this, all right? What does an exact answer mean? What does that mean? That means no decimals, okay? It means simplify the radical like 2 root 3. That would be a simplified radical. And then a simplified fraction. Okay, so in other words, if I have, I don't know, 2/10, I can't leave it like that. I have to write that as 1/5. Okay, we don't have a whole lot of fractions in this part of the unit, but we have a ton of radicals, right? So if you're giving an exact answer, you can't have any decimals. You have to simplify your radical and leave it as a simplified fraction. Okay, the other thing is if you're calculating circumference, area, all those things, which is what we did in the last part of the unit, you would leave your answer in terms of pi. That does not really apply for tomorrow's quiz, but I'm going to put that up here anyway. That's for area, circumference, arc length. Okay, so this part, that last one, that really won't apply on tomorrow's quiz, but the test that we have coming up, remember, will be cumulative and it's going to cover all 3 circle units. So we'll need to remember to do that by the test. And we will go over the last 2 tests before we have this test. So tomorrow's quiz will not cover the prior units. It's just what we've done. Okay? So let's talk about what's on tomorrow's quiz. Right? Okay, so it's on Go Formative during class. And the best way to figure out what is on the quiz is to look at the assignment sheet, right? And just if you look at what the topics are to be covered, that's exactly what's going to be on the quiz. All right, so we have, it covers 5.1 through 5.4. And 5.4 we're going to do today. So you have equations of circles. You have standard form. Right? And that's the one that's the nice one that we like to work with, right? So standard form of a circle. where H comma K, center. Remember, on standard form, you have to switch the signs. If you're going from the standard form to find the center, you have to switch those signs. It's the opposite. And same if you're given the center, the coordinates for the center, you would use the opposite sign to put it into the formula. All right? And then we have general form, and that's kind of the yucky one, right? All right, so what do you know about general form? You guys have it on your notes here. What order does it go in? Okay, yeah, so it goes in the order of X, then Y, but it goes in descending exponent order. So what does that mean, Andrew? Descending exponent order. Look at your formula. You want to get your notes out? That would be helpful, right? So you should have it at the top of your page because you want to make sure you know what the heck it means come test day, right? Or quiz day. Okay, so that's the general form of the circle. And the order matters, okay? Order matters when you write it in general form. The other thing you want to pay attention to is that, remember, we always set it equal to 0. Equal to 0, okay? So when I say the order matters, see how it's x squared, then y squared? That's what it means with descending exponent order. We have the x squared, then the y squared, then the x, then the y, then just the plain old number equals 0. And those A, B, C, D, E, remember, those are just constants. They're numbers that show up in front of the variable. And if there isn't a number there, the number is just 1, right? Okay. And if for some reason you didn't have, like, say you don't have a CX, there might not be an X term, I would still put what I do have in that order. Okay, so that was kind of what we did on 5.1 and 5.2. And then the next part, after equations of circles, so equations of circles, we're still doing equations of circles, but we're writing the equation given other points on the circle, right? So okay, so you should be able to write the equation given the center of the circle and a point on the circle. What else do we do? Remember the endpoints of a diameter? That was kind of the long one that we walked through yesterday with the midpoint. We found the midpoint. And then we used the distance formula. If the points are not easily able to fit on our graph, we had to use a distance formula to do that. And then we would put the equation in standard form. And then what we did yesterday was we converted. Yeah, that's exactly right. We converted from general form to standard form. Whoop, just getting too small here.
And stating the center.
Yeah, that's exactly right. And to do that, I complete the square. Right, and I might have to state the center and the radius. Okay. So it's a lot. It's a lot of algebra stuff that we're doing. Really, that's mostly what it is. Okay, so then today what we're going to do is find equations of lines that are tangent to a circle. A little bit. Okay. And that's kind of everything, which is, it's a lot, right? So if we go look at it all together, that's a lot of stuff. And I know my writing got smaller and smaller as we went, didn't it? Sorry about that. But anyway, if you look at 5.1 through 5.4 on Delta Math, you can look at your notes packet. And remember, you can go back through and do lots. There's a lot of problems in the notes that we didn't work in class. All of the answers to all of the notes problems are posted on CTLS. That's a great way to study for the quiz. Okay, so you want to check your answers and make sure that you're getting the same exact answers that we're getting. And if it's not exactly the same, meaning like same order, simplified radical, simplified fraction, like every single thing, you need to go back and look at your work and say, oh, wait, what did I do wrong? Okay. The other thing you have to study with okay, so you have your Delta Math homework. You have your notes with answers. You can work problems. And then check your answers, make sure they're right. Okay, you also have all these practice classwork, right? With the scrambled answers. These are in the more practice worksheet or folder. CTLS, okay? That's what this is. If you guys didn't get one of these, you people who are in person here, this packet has 5.1 through 5, the whole through 5.6 practice, okay? What else do we have? How else can you study? Anybody checked out the videos that I posted? Makes me look important. I have a YouTube playlist, right? But remember, I posted a bunch of videos on YouTube. Actually, I recorded yesterday's class session, and I'm going to post that video too. So if you need practice completing the square, you can go back and rewatch all the notes from yesterday, all the class notes, all the class lesson. I also put other things out there that might be helpful. We also did the first lesson on the circles, right? That video is out there. So that's a good resource if you just need a little bit of a refresher. The other thing is Ms. Rastogi posts our class notes every day. on CTLS. So let's say you zoned out for a second, which happens, I know, right? Let's say you zoned out a little bit and you just missed something important, like what did she say about this? Check the class notes that are out there, okay? And then the last thing we have is tonight you have your Delta Math assignment 5-4, but you also have the formative practice quiz. I think I call it quiz review, but it's basically like a practice quiz on Go Formative, okay? Okay, due by 8 a.m. Thursday, and this is a classwork grade. Okay? That's open now, so you can work on that today, now, in class. So I'm gonna try to give you some time to work on that.
There's a Delta Math as well.
There's a Delta Math 5-4 and there's a Go Formative. One of the main reasons I want you to do the Go Formative, I know you have a lot of other resources out there, but once you get to the quiz, I don't want you to be nervous about how you're entering equations of circles at the time of the quiz, right? So I want you to be able to practice entering your answers, clicking on the keyboard, all that kind of stuff. And it's not too bad. I just want you to be comfortable when you take the quiz. Okay? Any questions about that? Okay, we're gonna do just a couple problems on 5-4, and then I'm gonna answer the homework questions that you guys had, and I'm gonna give you time in class to work on your homework on Delta Math, and actually preferably maybe do that, get started on that Go Formative activity. The quiz review, the practice quiz on Go Formative, it will let you start working on it and go back to it. There's no time limit on that. It's not like a regular quiz with timeout, right? So you can work on part of it and then go back to it later. All right. So, okay, here we go. On 5-4, okay, you have notes in your packet and posted on CTLS that go with our lesson 5.4. Okay, what we're going to do in this last lesson that will be on our quiz is we're going to write the equations of lines that have to do with circles. In most cases, it's writing a line that's tangent to a circle. Okay, so a couple refreshers. Do we remember how to write the equation of a line? Hopefully, I hope by now. But sometimes people get confused about which format is which. So you probably want to write this maybe on the back of your assignment sheet or wherever you're keeping all your formulas, because you can use your notes for the quiz, right? So you don't want to be confused, and I have this for tomorrow. So we basically have two formats that we use for equations of lines, right? The one you probably learned first and in middle school is slope-intercept form. And it's exactly how it sounds, right? It's y equals mx plus b, where m is the slope and b is the y-intercept, right? That's kind of the most common one that we're familiar with. Yeah.
Why does it say y minus y1?
Okay, over here, this is point slope form. And this one, I think, is not as common in middle school, right? But we use it a lot in high school. And what this means, when you write point slope form, remember you do y minus y1, y1 and x1. These are numbers that you're going to get from a point that you're given. So, like you're going to be given this. Like it might say, write an equation of a line that's tangent to the circle at point 3, 2. If we give you a point 3, 2, x1 is just whatever the x value is, and y1 is whatever the y value is. Okay? So we'll do a couple like that. So a couple of other things. You remember when we did circles? We've been doing circles forever, it seems, right? All right, so we have a circle. And we have a radius. That's my radius, R. What do I know about a line that's tangent to a circle? There you go. Ah, you guys are awesome. Okay, that's tangent, right? So if a line is tangent to a circle, it touches a circle in exactly one place. And I don't know if you guys could hear them shouting out here, but they all shouted out, it's perpendicular to the radius, right? Remember all those right triangle problems we had to do? Okay. So that's going to be really important when we're writing the equation of the tangent line. And when you have two slopes that are perpendicular, so if I have the slope, and we'll call it M, is the slope of the radius. What would be the slope of the tangent line?
You would use point slope for this, right?
Yeah, you can usually. How would I write the slope of the tangent line? Remember? So if it's perpendicular, so it's like the perpendicular slope, and we would write it like this. Sorry, I'm trying to scroll down on my board here. It's perpendicular to M. So remember, you change the sign and flip it. It's the negative reciprocal or the opposite reciprocal. So let's do it with numbers here instead. All right, so let's say the slope of the radius, let's say that's 2. Then the slope of the tangent line would be the perpendicular slope to M would be -1/2, -1/2. You remember that? Kind of, sort of. We did like a whole unit on this last semester. Right? So that's going to be the most important thing when we're writing the equation of tangent lines. We're going to find the slope of the radius, and then we're going to get the perpendicular slope for that. Okay, so on your notes, whoops, sorry, here we go. On your notes, so you should have all these notes in your packet, the 5-4. And we're going to do several, but not all of these, but I at least want to get through this first one for sure. And then I see a couple more questions in the chat, and just know I got those messages, those questions, and I will answer them as soon as I finish this. Okay, so a couple things. On number 1, sketch the graph of the circle with the equation that's given to us here. And that's given to us in standard form. So now on Go Formative tomorrow on your quiz, you're not going to graph. You're not going to have to actually graph anything, but you might need to identify what the correct graph is. Okay? And you might have to write the equation from a graph, but there's no real good way for us to have you graph on the online test. So, but let's do it here so that we know what we're doing. So first thing I'm going to do, right, is enter the center, which is what? -3, 2, awesome. And the radius, which is what? Awesome. So it's the square root of 25, which is 5. Okay, so remember that when you have standard form of the circle, the number after the equal sign is the radius squared. So you have to take the square root of that to get the radius. I think that was one of the questions that somebody just asked me. All right, so the center is at -3, 2. So let's go ahead and graph that first. I'm going to go over -3 to 2. That's the center. Oh, I sure did. Thank you. Okay, -3, 2. Thank you. -3, 2. And that's the center of the circle. And so when I graph this, the first thing I want to do is just count kind of north, south, east, west around the center, right? So I'm going to go up, left, down, and right. 5 squares. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Well, here it says show 12 points. How do I do that? Now, normally I would just require you to show 5 points. Well, it's giving me a hint on this problem. It says 1, 5 is on the circle. Okay, so let's do 1, 5. All right. So if point 1, 5 is on the circle, to get there from the center, I'm going to go over and up. So I go over 1, 2, 3, 4, and up 3 spaces. See that? Which means I can also go in just kind of like I did the radius. I went up 5, left 5, down 5, right 5. I can do that same thing. And if you can envision, kind of you're making your triangle all the way around. So I have to the right 4, up 3. Then I can go to the left 4, up 3. It's going to be another point. I can go to the left 4, down 3. And to the right 4, down 3. Can you see that? Lots of dots I know on here. All right, the other thing I can do is I can go flip these, and I'm going to go to the right 3 and up 4. And that point has to be on the circle as well. So over 3, up 4. Over 3, down 4. And over 3, down 4. And that's how I get 12 points on the circle. Can you see that? So if I connect my dots, try to connect my dots here, make it a circle. That's pretty good, right? So the center of my circle is still right there. Okay. So now we have our circle graph. And I'm going to write on part A here, I want to write the equation of a line that's tangent through the point 2, 2. All right, well, first let's find point 2, 2. I'm going to use purple to find point 2, 2. All right, the 2, 2, that's this red point. So if it's tangent to the circle, remember you guys just told me, oh, it has to be perpendicular to the radius, right? So if it's perpendicular to the radius, let's draw our radius here. This is my radius, that blue line right there. So what's the slope of the radius if it's horizontal like that? You remember? 0, exactly. The slope of the radius would be 0 there. So I need to find the perpendicular slope, which would be the undefined one. On this particular one, it should be pretty easy to say, well, the perpendicular line, it makes a right angle, so my perpendicular line to this radius, do you see how it just has to be up and down vertical here? It has to make a right angle there. Okay, so we're finding, oops. This is the tangent line. It's perpendicular to the radius at the point that we were given over here, Q2. Okay, we always have a little bit of trouble with, is this an x equal line or a y equal line? Remember? What's that box, boy? It is x equal, right? So it's going to be x equal Q. Okay? So if it's a vertical line, I'm holding x constant. X never changes. It's always 2.
How did you get the green again? The green dots.
The green dots, I switched, and don't worry too much about that because we're not going to make you graph actually on the quiz tomorrow. But I know that if I go over 4, up 3 to get to the blue dot is on the circle, I can also switch that and go over 3, up 4, and that will also be on my circle. It'll also work in my equation here. If you think about what it's making is a 3, 4, 5 triangle, where that's the radius. Okay, the question was, how did I get to the green dot? Okay, don't worry so much about that. The equations of the lines is more important for these notes, right? Okay, so are we good with how we got the red line that's tangent and how we got the equation of that line? We're good? We're good here? Are you guys good? Okay, so next one, let's do tangent through -3. We'll do B, -3, 7. So if I go to -3 up to 7, that's this point right here. Okay. So if I draw in my radius, let me keep my radius blue. Now the radius is going from here to here, right? It's still the radius. So tangent to the radius has to be perpendicular. So what's that going to look like? Here. Right, because it has to make a right angle with the radius. Okay. -3, 7. Okay, so that's the green line. It's tangent to the radius at the point -3, 7. So what's the equation of that one? Y equals? Brilliant. Okay, you see kind of a clue here when you're given the points. If it's going to be an x equal equation, you just put x equal whatever that point was given to you, right? If it's a y equals, it's y equals the y coordinate. Now that only works if you have a vertical line, right? This one's vertical and this one's a horizontal. Okay, so that's why it helps even if you're not asked to graph it on a problem like this, on a quiz, if it says write the equation of the line that's tangent to the circle, and all we give you is the equation, if it fits on a graph, like it will, what should you do? you should graph it, right? On your scratch paper. You should have scratch paper, which we've posted on CTLS. We've posted that scratch paper for graphs on CTLS. So for your quiz, you want to have some blank graph paper there so you can sketch out your circle and solve it graphically. That's a heck of a lot easier than solving it with formulas. Okay? Okay, so the next one's a little bit harder, right? It's not going to be vertical or horizontal. This next one here, tangent through the point 1, -1. 1, -1. All right, so that's the point I need to go through. That's 1, -1. Well, this is a little bit more complicated because when I draw the radius, and again, I'll make it blue. And I realize there's a lot going on this picture here now. But that radius is blue, right? So I need to find the line that is perpendicular to the radius at that point. So when I do that, if you notice right under C here, it has all the steps that I need to do. So the first thing is I want to find the slope of the radius right here. So find the slope of the radius. So how can I do that? Since I graphed it, what's the easiest way to do that? Can I do rise over run? So that's 3. And that's 4. And it's going that way. So what do I get, Andrew?
But you gotta do that.
Yes, go ahead. Okay, so the slope of the radius at that point is -3/4. Outstanding. So then I need to get the slope that's perpendicular to that. And remember the perpendicular slope, we have to flip the sign. It's -1 over m. You can kind of write it like that to help remember if that doesn't confuse you. The perpendicular slope would be, change the sign, we get positive 4 over 3. Right? Yes. It is, yes, so it depends how, there's a lot of different ways to think about this. So I want to answer it the way you're thinking. The question was, is it a negative slope because you're going down 3? Yes, so if you start at the center and you have to go down 3, right 4, it would be negative. Okay, you could think of it as like -3 there. Or the way I think of it and the way I always teach it is if you face the graph, if you raise your right hand and the line goes up with your right hand, that's positive. Because people like right-handed people. I don't know, it's a positive thing. So I'm left-handed, right? Raise your left hand. Some people think that's a negative. I don't really think it's a negative, but it helps me remember the slope. So if you raise your left hand, it's negative. So that's one way to remember it. But yes, if you're counting and that works for you, perfect. Yes. Kate.
Wouldn't it be -4 over 3? That's reciprocal.
You have to change the sign. It's the opposite reciprocal. So change the sign and flip the fraction.
So the only sign that we change is -3, +4.
Yes.
Okay.
You just change it. So if you start off with your number as negative to begin with, it's going to end up positive. Don't change the top and bottom. Just one. Just think you're only changing the sign in one place. Okay. So I have 4/3. So let's keep going. So I'm at this. Oops. Let me keep it purple. I'm at my purple point, right? And I want to do the slope that's 4/3. So in this one, I can count from here and I can go up 1, 2, 3, 4 over 3. And I could do it again. Right? And I could count. There. And just to double check, does that look like it's perpendicular to the blue line right there? Yeah, it does. Okay, so it's a good way to kind of check yourself, is just sketch out the graph. And then when I have to write the equation, I could write the equation of the line from the graph, or I can use the equation and fill in the equation. But here it's saying, if I write it in this point slope form.
Good morning, may I have your attention, please? At this time, please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Please be seated. We will now pause for a moment of silence.
I'll finish this once the announcements are over. I'll finish this and answer the homework questions also, so hang on.
We have one announcement this morning. Varsity soccer will host Harrison on Friday night for a big region match. We need everyone to come and support in Raider Valley. The first 50 students will get free entry to the matches. The girls will play at 5:30 p.m. and the boys play at 7:30 p.m. Concludes our announcements this morning. Everybody have a great day.
Okay, so we wrote the equation of the purple line here using the point slope formula. So make sure that makes sense to you. So we use this point here, 1, -1, and I plugged it into the point slope formula, which they have written for me way up here. You see that? So it's y minus y1. So y is negative, so it's going to be y plus 1 is equal to the slope times x minus the x coordinate. Okay. Okay, and then just to finish this problem, the next question says, will the tangent through 0, -2 be the same? Well, it's not. 0, -2 is that point there. And if you can picture kind of a wheel going around, like a Ferris wheel, that purple line that we just did was tangent to the circle at the point 1, -1. The green line would have to go like tangent to the point 0, 2. It would have to kind of be, it would be a different slope, right? It would be a little bit flatter slope. So if you can kind of picture it as like a wheel turning around, and the slope of the line is going to change as you go around that wheel. It's just kind of getting you to think conceptually. So no, that's not. That kind of question wouldn't be on the test, but writing the equations, just those 3 things, will be on the quiz. Okay, so I'll post my notes if you need to look at it again for a refresher, and but just those basic things. And so if you use your graph paper to graph it, it's much easier because you can count the slope. Just remember, you're going to find the perpendicular slope for the radius. So you find the slope of the radius, then find the slope that's perpendicular to the radius to write your equation. So you can use your notes here on your quiz tomorrow, and if you just follow these steps, if you have to write the equation of a line that is not just either vertical or horizontal, these are exactly the steps that you would follow. Okay. Okay, let me pull up the Delta map really fast because I know you had some questions on that. Okay, and then Nell, did I answer your question?
Yes, you did. Thank you.
Okay, awesome. On question on 5.2, question 3. Okay, right? Kenneth, is that the right one? Okay, he logged off, so never mind, we won't do that one. The other question was, let me look. From last night's homework. Question 3 last night, and okay. Question 5 from last night. Okay. So who asked that? You in here? Is it somebody in here also?
I asked.
This one? Okay. So when they give you a point on the line like that, what I need to find here is the radius. Right? So I can write the form of the circle. This is the center right here. So it'd be x plus 5 plus y plus 6 squared equals r squared. So I need to find that. And when I find that, I can use the distance formula, or I can make the little right triangle, right? So if I make a right triangle, if they give you a graph, I think that's the easiest way to do it. So if I make the right triangle, this is 2 spaces and this is 3 spaces. Get a little bit bigger. So this would be the radius. That's 2 and that's 3. So to find the radius, I say 2 squared plus 3 squared is actually r squared, which is all I need. So you don't even have to take the square root. R squared is 13. R, the radius, is the square root of 13. I believe on this problem, they want us to enter the equation, right? Let me put it back there. So when I write the equation of the circle, I'm just going to substitute 13 for that, right? So this would be the equation. Yeah, if you want to take a picture, take a picture. That's fine. All right. Oh, Kenneth, you are here. Okay. Is that the question you had? Okay. Anybody else? Let's see. Number 5, write the equation of a circle given the ends of the diameter. Okay. Thank you. Yes, that was the other one. So the other one was question 5. Oops. Sorry. I'm just gonna do it based on what you said the endpoints one were. So it says ends of the diameter -2, -18. Make sure I got the right numbers. -2, -18, and 0, 0. Those are the ends of the diameter. Okay, so when I'm writing the equation from this, remember the steps I need to do. I need to first use the midpoint formula because this doesn't fit on the graph. Otherwise, if it were small, I would say graph it and count. That's the easiest way. But you're going to use the midpoint formula to get to the center. And then use the distance formula with the center and one endpoint they gave me. All right. And in this problem, which endpoint am I going to pick? The easy one. Okay. So let's do the midpoint. So to get the midpoint, you just average the x values. So that means I do 2, -2 plus 0 divided by 2 is the x. That's that. So the center. Bye, you guys have a great day. -1, -9. Bye, you guys have a great day. And then I'm going to use the distance formula to find the distance from 0, 0 to the center. Okay, so the distance, which will be the radius, will be the radius is 80, square root of 82, but r squared is 82. So the equation, if I come back up here, I'm going to write it at the top. It won't let me scroll now. Let's see, I lost my center. Where's the center? Here. This is the center, right? So I'm going to have x plus 1 plus y plus 9 squared equals r squared is 82.
We box that and so we do that.
You see it? Sorry.
Thank you so much.
You see it, Gracie? Did that help?
Yes, that helped a lot. Thank you.
Is that good? Yeah, I think you're muted, but that helped.
Yeah.
Awesome. Okay.
Oh, that's our goal.
See you later. Good. Okay, I'm glad you got it. And then check the notes because we did a lot of those problems and you can see them step by step.
Okay.
All right. Bye, you guys. Have a great day.
Oh, we just don't have enough time, do we?
I'm going to bell to bell through homeroom. Like,